There are two questions given here, but in exam we can choose either first one or second one. Let us discuss both. So first we'll discuss question A. Here the question is, show that an ideal inductor does not dissipate power in an AC circuit. So let us consider the AC circuit with inductor L. Now, the current and voltage relationship in an inductor is V equal to V naught sine omega t and I equals to I naught sine of omega t minus pi by 2. See here, V naught is the peak voltage and I naught is the peak current and omega is the angular frequency of AC signal. Now it is right, instantaneous power delivered to the inductor is the product of instantaneous voltage and current. So what is I here? I naught sine of omega t minus pi by 2 into V is nothing but V naught into sine of omega t. So now we can write minus I naught V naught cos omega t into sine omega t. So we have minus I naught V naught divided by 2 into sine 2 omega t. Now average power of a complete cycle is PL, which is equals to minus I naught V naught by 2 into sine 2 omega t, which is equal to 0. Because the average value of sine 2 omega t over a complete cycle is 0. So this average power dissipated over a complete cycle also 0. Now let us discuss question B. For solving question B, let us consider the figure. This is resistance ohm. We have the value 20, 40 and 60. Here we have 100, 200 and 300. See here the question is the variation of inductive reactance XL of an inductor with a frequency F of the AC source of 100 volt and variable frequency is given in the figure. So now let us take the self-inductance of the inductor. So in this one we are going to calculate the self-inductance of the inductor, and the second question is, when this inductor is used in series with a capacitor of unknown value, a resistor of 10 ohm at 300 per second. So first one will take self-inductance of the inductor. So self-inductance of the inductor XL, we know that equals to omega L, and we know that omega equal to 2 pi F. So we can write L equal to XL by 2 pi F, so which is equal to 20 divided by 2 pi into 100, so which is equals to 40 divided by 2 pi into 200, which is equal to 16 pi 2 pi into 300. So all are equal. So if we simplify this, we get the value of 31.84 into 10 power minus 3. So this is approximately equal to 32 mH. So now this is the self-inductance of the inductor, 32 mH. Now let us discuss second question. In this question we are going to calculate the capacitance of the capacitor. So now we'll write maximum power dissipation of the circuit occurs at resonance. At resonance we know that XL equal to XC, or we can write omega N, which is equal to 1 by omega C. So we can write C equal to 1 by omega square L, because we are calculating the capacitance of the capacitor. So we can write C equal to the value of omega is 2 pi F. So if we substitute 2 pi F here, we'll get 4 pi square F square L. So now let us substitute the value of pi, F and L. So 4 into the value of pi is 3.14 into 3.14 into the value of F is 300 into 300, and the value of L is 32 into 10 power minus 3. So if we simplify that, we get the capacitance is 8.8 mu F. Now let us discuss our question. See here we have question A and B. So in our question we'll discuss first one A. Here the question is the conductor of length L is rotated about one of its ends at a constant angular speed of omega in the plane perpendicular to a uniform magnetic field B. So they're asking us to plot the graphs to show the variations of the EMF induced across the ends of the conductor with angular speed omega and length of the conductor L. So now let us take the length of the conductor L, which is rotated at the angular speed of omega in the magnetic field B. So the first one is EMF induced across the end of the conductor with angular speed. So EMF induced at the rod, we can write minus d pi by dt. So we can write the EMF induced equal to 1 by 2 B L square omega. So now first thing we'll get the graph, angular speed and the EMF induced. So now let us take the angular speed omega in the x-axis and the EMF induced in the y-axis. So here the EMF induced and the angular speed both are directly proportional, so we'll get the linear graph like this, right? Now the second thing is we are going to get the graph for EMF induced and the length of the conductor L. So here again we know that E equal to 1 by 2 B L square omega. See here if we substitute the value of E and L, because here we have L square, so we get the curve like this. So this is the graph for EMF induced and the length of the conductor L. Now let us discuss question B. Here the question is two concentric circular loops of radius 1 cm and 20 cm are placed coaxially. So the first question is find mutual inductance of the arrangement, and the second question is the current passed through the outer loop is changed at the rate of 5 angstrom per meter second. So find the EMF induced in the inner loop and assume the magnetic field of the inner loop to be uniform. So here they are saying that two concentric circular loop of radius 1 cm and 20 cm placed coaxially. So the first question is find mutual inductance of the arrangement. So let us find mutual inductance of the arrangement. If current I flows through the large coil, so magnetic flux linked with the small coil will be M pi. So magnetic field of the center of the loop we can write, so B center into pi into 10 power minus 4. So and B center, magnetic field of the center is nothing but mu naught I divided by 2 into 20 into 10 power minus 2 into pi into 10 power minus 4. So from this we can write M equal to mu naught pi by 4 into 10 power minus 3 h. So we have 4 pi into 10 power minus 7 into pi into 10 power minus 3 divided by 4 h. So if we simplify this, we get 9.9 into 10 power minus 10 h. So approximately we can write M equal to 10 power minus 9 h. So this is the mutual inductance of the arrangement. Here the second question is finally EMF induced in the inner loop. So let us write the EMF induced in the inner loop, which is equal to minus M into di by dt. So from the previous question we know the value of M is 10 power minus 9. So we can write minus 10 power minus 9 into di by dt. So already they are changed, which is given that the current passed through the outer loop is changed at the rate of this value, right? So we write 5 divided by 10 power minus 3. So EMF induced can be equal to minus 5 into 10 power minus 6. So this is the EMF induced.
They offer